Voyager 1 is the furthest man-made object from Earth ever created. It is currently 24 billion kilometers away from us, and it's not slowing down. Right now, it is speeding into deep space 14 times faster than a bullet, but last November, Voyager 1 went silent. But just a few weeks ago, NASA revived Voyager 1, and all systems are now back online. Voyager 1 lives to see another day. This did have me thinking, how much further can Voyager 1 travel before it runs out of power or we lose contact with it? If this famous image of Earth was taken by Voyager 1 back in 1990, what if we turned on the cameras now? What would we see? And maybe most importantly, what happens thousands of years from now if humanity is no longer around and something, or someone, finds Voyager? So let's go on a journey together. Voyager 1 was launched on September 5th, 1977, sent on a journey for the outer solar system to investigate the beautiful gas giant planets, before leaving our solar system on an endless and lonely journey into the cosmos. I've told you that Voyager 1 is the furthest man-made anything from Earth, but it's kind of hard to truly grasp just how far away it really is. This is our Earth and Sun. The distance between them is known as an astronomical unit and equal to around 150 million kilometers. Voyager 1 launched from Earth on September 5th, 1977 on a journey to leave our solar system for good. Traveling at 61,000 kilometers per hour, it took 1 year and 6 months for Voyager to travel 5.2 AU, passing Jupiter, taking these jaw-dropping images in the process. 3 years and 2 months after launch, and Voyager had made it to Saturn. That's when its long and lonely journey really begun. It would take a further 31 years of travel at this immense speed to finally pass the heliopause boundary. This is the point where the sun's solar wind is no longer strong enough to resist the interstellar medium. It's essentially the boundary of the sun's influence. And while you might think this is the boundary of the solar system, you'd be wrong. Let's zoom all the way forward to today. In 2024, Voyager 1 is around 24 billion kilometers away from Earth, or around 163 AU. That is more than 4 times the distance from the Sun to Pluto. At this distance, it takes our radio signals 22 hours and 36 minutes to make it to Voyager, and a further 22 hours and 36 minutes to receive any messages back. While I know this seems so far away, in the grand scheme of things, Voyager 1 has barely left home. It will take a further 300 years before Voyager 1 reaches the Oort cloud, a sphere of icy rock surrounding our solar system, and it will take a further 30,000 years to completely pass through it. Now think about where Voyager 1 might be in a million years from now, a billion years from now, and who might find it. So I guess the question is, how do we even stay in contact with Voyager 1 if it's just so far away? Really think about that. NASA engineers saved a spacecraft launched nearly 50 years ago remotely from Earth. That's pretty special. NASA communicates with Voyager 1 using their Deep Space Network, a system of huge telescope antennas located all around the world, in California, Australia, and Spain. These locations were specifically chosen so communication can be maintained throughout the entire day as Earth rotates around. Radio signals are sent from Earth and then take around 20 hours to reach Voyager. Once the message is received, Voyager's onboard computers can process the instructions before sending a response back to Earth. This response signal again takes around 20 hours to reach us, where it's then received by massive 70-meter wide radio dishes and an array of these 34-meter dishes. To give you a scale of just how weak the signal sent from Voyager is, the radio signal is sent back by a transmitter with a power level of 20 watts. That's about as strong as the light bulb in your refrigerator. Despite how weak the signal is, the huge dishes on Earth are able to capture these whispers from the cosmos, allowing for data about what Voyager 1 is experiencing out there to be received here on Earth for hours every single day. But signs of Voyager's age is showing. In November last year, Voyager started sending back random strings of data that made just no sense. Now, of course, conspiracy theorists jumped on this, claiming that aliens had captured Voyager 1 and were using it to send messages back to us here on Earth. This is, of course, not what happened. Engineers located the issue with the flight data subsystem, created a workaround, sent the code to Voyager, and waited to see if it worked. And Voyager 1 survived. Communicating with Voyager doesn't seem to be the problem. So why then is everyone saying lately that Voyager is dying? The real answer is Voyager's running out of power. Voyager 1 is powered by 3 radioisotope thermoelectric generators, or RTGs. These are nuclear reactors converting heat from plutonium decay into electricity. But this of course means that over time, the fuel source gets used up. To conserve power, NASA engineers have been turning off the non-essential systems and instruments. Things like heaters and redundant scientific instruments, including the camera. NASA have said that sometime over the next few years, the power levels will just be too low to support the critical systems. And at this point, Voyager 1 will go dark forever, drifting through the cosmos, alone for eternity. Valentine's Day 1990, Voyager 1 was 6.4 billion kilometers away, leaving our solar system for good. But down here on Earth, a man had been campaigning, saying we should turn Voyager 1 around one last time to take a picture of Earth. Everyone said it would be a waste of energy and there was no scientific value in taking that picture. But he insisted, and thankfully NASA agreed. This man was of course Carl Sagan, and the image we received, the pale blue dot, maybe the most iconic image of Earth ever taken. In this picture, Earth is just 10% of a single pixel in size, captured as a tiny speck in a scattered light ray. And yet, that's all we know. That's where you are, right now. This has me wondering, since Voyager 1 is about to go dark forever, what if we turned it around one last time and turned the camera back on to take one big family portrait? What would it see? So I did some simulations, and this is what I came up with. The sun visible as a faint and blurry dot of light surrounded by planets you can barely make out. So while the pale blue dot showed us our home, this is our cosmic neighborhood, our planetary neighbors lit by the sun. And because the universe is just too big, this is probably all humanity will ever know. For the rest of time, this is our home. As Voyager 1 shuts down operations in the coming years, it's hard to not imagine what the future holds for this amazing spacecraft. Once the onboard power is depleted, the instruments will no longer work, and no more data will be sent home from Voyager. The end of an era. But for Voyager, this is still just the beginning of its journey. It will continue through the Oort cloud for thousands of years, finally leaving the outermost extent of our solar system for good. It's out here where Voyager will orbit our Milky Way every 225 million years, just like us, passing by neighboring stars every now and then, a beacon of our humanity. And if someone is out there looking and stumbles across Voyager, they will have all the clues they need to find us. The Golden Record contains everything they need to learn about our little blue dot, what animals we have, what our languages sound like, many images and audio recordings, and most importantly, where they can find us. So when that day does come, when Voyager goes quiet for good, we can all agree that Voyager 1 completed its mission and much, much more, giving all of humanity a beacon of hope.